Okay, so question 6. The switch was open for a long time. At time t equals 0, the switch is closed. Okay, what is the voltage VAB at time t equals to 0 plus? Okay, so again, we will start off with the first principles, correct? So we know that t equals to 0 minus, okay? What we know is the circuit is open circuit. Okay, the open circuit means there is no current flowing. If there's no current flowing, we can say that the IL is 0 and the VAB is also going to be 0. Alright, at t equals to 0 plus, again, the current through the inductor cannot change instantaneously, which means that VAB is also going to be still 0. Alright, so that is this first question here. And then they ask, what is the ILT at time t equals to 1 millisecond? Okay, so at time t equals to 1 millisecond, okay, your current is now flowing through the inductor and these two resistors, correct? So we can use the expression, okay, as we know it, which is IL 0 e to the minus t by tau plus IL infinity 1 minus e to the minus t by tau. All right. Now we know that the initial current is 0, so this part we can ignore. And what would be the final current? The final current would be when I reach steady state, which would be your inductor being a short circuit. Okay, so an inductor being a short circuit, you basically have this with two resistors in parallel. All right. Okay, and from earlier lessons, we know that when I have resistors in parallel, okay, when they are both extreme values, correct, when one is very small and one is very large, okay, the equivalent resistance will be very close to the smaller value. Okay, very close to the smaller value. So 10 parallel to 10k, you can approximate it to be 10. Okay, if you put in a calculator, you get also very close to 10, 9.9 something, whatever. All right, so with that, okay, you can simplify this circuit to say that this would be the expression, okay, or the final circuit. That means it's something close to 10 volt and 10 ohm, okay, with a 10 milliamp Henry here. All right, so if I put in this into my final expression here, so what I will get here is the current through the inductor at steady state will be 10 over 10. Okay, which will be 1 ampere. All right, so this current IL, okay, will be equals to 1 minus e to the minus t by tau, and the tau in this case will be L by R, which is 10 milli over 10, which will be 1 millisecond. Okay, so at 1 millisecond, okay, which is 1 tau, my value, okay, for the charging would be 63.2% of the final value, which will be 0.632 ampere. Okay, when you're discharging at 1 tau, this is 1 tau, correct? When you're charging at 1 tau, you hit 63.2% of the final value. When you're discharging, you will hit 36.2% of that. 36.8% of that. Okay, so that's how you get the IL as 0.632 ampere here.